Panel is stable. Now for the voltage test. Readings are good. All systems go.
Hello everyone, welcome to Marine Electrical Made Easy. Today we are going to learn how three-phase AC supply is produced inside a generator, especially the type used on board ships. Let us begin. Inside an alternator, we have a rotating magnetic field and three separate coils placed 120 degrees apart from each other. These coils are called phase 1, phase 2 and phase 3. As the magnetic field rotates, it cuts across each coil and produces voltage by electromagnetic induction. The voltage generated in each coil is an alternating current, meaning the direction and magnitude continuously change with time. Because the three coils are physically separated by 120 degrees, the AC voltage produced in each phase also differs by 120 degrees. This is why the three waveforms rise and fall one after another in sequence. When phase 1 reaches maximum voltage, the phase 2 and the phase 3 are delayed by 120 degrees. This arrangement produces smooth and continuous power, which is one major advantage of three-phase supply. On ships, the three-phase AC power is widely used for large motors, pumps, compressors, winches and propulsion systems because it is efficient and reliable. The three output terminals are commonly named red, yellow, blue, or sometimes U, V and W. The most marine generators, the standard supply is 440 volts, 60 hertz and three-phase supply, three-phase. Now you can see in the screen the ship's generator. So the ship's generator will be something like this. And there is an alternator and the prime mover. You can see from the screen. So to summarize, three coils are placed 120 degrees apart. A rotating magnetic field cuts the coils and three separate AC voltages are produced with 120 degree phase difference. This is the basic production of three-phase AC supply. Thank you for watching Marine Electrical Made Easy. If you enjoyed this video, please like, share and subscribe for more simple marine electrical lessons. Thank you.